Function pointers. What are they and why might one need them are the questions that I'll be answering in this episode of Demystifying Pointers. We've looked at pointers before. These are special variables capable of holding addresses. Note that functions also start at an address in memory. A pointer that holds that kind of an address is a function pointer. Take a look at this bubble sort routine. It sorts an array of numbers in a non-decreasing order. The order in which it sorts the array is determined by this line here. This line swaps the consecutive numbers when the next number is smaller than the current one, moving the larger ones to the right, hence resulting in a non-decreasing order. If we wish to sort the numbers in a non-increasing fashion, we just need to change the relational operator to be less than. But then we would change the function. What if we wanted to be able to do both in the same program? We could write two of these with different names like so, with just that tiny difference of that one operation. But the rest of the code is repeated, and code repetition is almost never desirable. So let's get back to our bubble sort and take a look at the line that is comparing things. This decides how the array is going to be sorted. We, as users of this function, currently have no control over how it's comparing things. The solution would be to pass to our function another function of our own that decides on how things should be compared. Then, bubble sort could make a call to our function like so. This would make the function generic as to how it sorts the array, but to make this function capable of taking in another function CMP, we have to make it take another parameter that is capable of holding a function, and that will look something like this. And the new parameter has to be a function pointer. The way we pass a function to another function in C is by means of function pointers. The declaration of a function pointer will determine the types of functions it can point to or hold addresses of. That's basically what a declaration is. A function pointer is going to have these three things: a return type, a name, and the number of parameters it takes and their types. The star indicates that it's a pointer, and the parentheses around here are necessary to indicate that it's a function pointer. And the next set of parentheses contain the parameter types, which will implicitly indicate the number of parameters that a function being pointed to by CMP can take. So CMP is capable of holding addresses to functions that return an int and take two int parameters. Look at how we're calling CMP inside our bubble sort. We're passing it two ints and expecting a 1 or a 0 as its return value. And this does match with our declarations of CMP, returns an int and takes two int parameters. Let's write our comparison functions now. Here's one. This will make the array be sorted in a non-decreasing order. Here's another, which will make the array be sorted in a non-increasing order. Here's one more. This one will make the array be sorted based on the tens digit. Now that those functions are there in our program, we can call them like so, as bubble sort is now capable of taking a comparison function as its third argument. So, the first one will sort nums in a non-decreasing order, the second in a non-increasing one, and the third in a non-decreasing order of the tens digit. Function pointers helped in reducing code in this scenario and made our bubble sort more generic. Other use case would be timing functions, a function that takes another function as its argument and calculates the time of its execution. That should do it for function pointers. Thanks for watching.